All right, we're gonna make another one. This is so much fun. You are going to now talk about graphs and what they have to do with functions. What does a function look like on a graph? What does a function not look like on a graph? That's the goal. I'm gonna share my screen and we're gonna get started. This is where we're at in the book, functions. We're through 3 full sections out of 18. So we'll see how far we get. I think that if we can kind of hit a stride, we can probably get through the whole book still, or most of it at least. I'd like to at least get to the beginnings of quadratics. All right, so we've just talked about roses are red and flower power in the last assignment. We made these tables, and 12 roses cost $29 and so on and so forth. Clearly, flower power for small numbers like 1 through 43 costs a lot more than roses are red. But in the last assignment, at the very end, we realized, oh my gosh, actually, if you're ordering like 200 roses, flower power is a better deal. Something to think about. And that's something we would do in math very often. Try to optimize something, figure out where do 2 things cross? Where does one get more expensive than the other? Useful stuff to know. All right, so we got these. As you learned in the previous one, we can write these as functions. We can use the functions. We can make tables. That's lovely. What would the graphs of these look like? And how could the graphs help them decide which company to use? Let's find out. First of all, you learned one of the first steps in creating a useful graph is labeling the axes appropriately. Can you solve the puzzle to show where the axes go? Which one do I label where? Does it go like that, or does it go like that? Giving you 5 seconds. 5, 4, 3, 2, 1. Pause if you need more time, but I'm going to tell you right now, in our last assignment, we talked about how the cost depends on how many flowers you order. That's how it works. So remember this, the independent, the thing that doesn't depend, is always X, always. So we just said the cost depends on how many flowers. So this right here, cost, it's dependent. It's supposed to go there. Whereas the number that you order, that's independent. That's what causes the cost to change. And so this is our setup we want. Just so you know, I already downloaded this assignment. That's the first thing we need to do. We need to write that this is the cost. And this right here is the number of flowers. Boom. If I could write sideways, I would, but it's not worth it. So we just get that. That's fine. That's fine. Okay, next we're going to use some questions to analyze some things having to do with the flower company. We'll come back to that in a moment. Back to this guy. So we did that. Good job. Oh my gosh, good work. We did it. Next, remember that the domain of a function is the set of values for the independent variable, which is x. The range of a function is the range of a function is the set of values for the dependent variable, which is y. What value depends? What value makes sense for the number of roses that they can order? What values make sense for the cost of the roses? So let's think about this. How many flowers can they order? Well, they can order 1 or 2 or 3 or 4 or 5 or 6 or 7, but they can't order 7.5. So we only want counting numbers for our inputs, right? Because you can only order counting numbers of roses. And that's going to affect how much we get charged, because we can't get charged for 5.5 roses, only for 4 or 5 or 6 or 7 roses. So the number we order can affect the costs we can get. Here's what I would type into our assignment. What values make sense? Well, the domain, which is roses, number of roses, that you can possibly order, is gonna start at, you could order 0. It's gonna be 0 or 1 or 2 or 3 or 4 or 5, or well, all the way up to n. We could order n roses. I like to use n, like we've talked about before, because n is for counting numbers, and we only want a counting number of roses. We do not want 5 3/4 of a rose. All right, so there we are. The range, on the other hand, is going to be, that's cost based on we'll just say the cost, that's fine. Obviously, it depends on how many roses we buy, and that's why the cost will have something to do. The first one, if I buy 0 roses, then my cost would be 0. If I buy 1 rose, then my cost would be $20 plus 75 cents. You remember that? It'd be 20, 75. And then if I buy 2 roses, that's going to be $21.50. You can go back and double check this. If I buy 3 roses, that's going to be $22.25. Buy 4 roses, that's going to be $23. And so on and so forth. It's always going to be $20 plus 75 cents times however many roses I buy. We did that in the last assignment. Hopefully it makes sense. Okay, so that is for roses are red. For flower power, we're going to have a lot of the same things. What is the same? Think about that for flower power. Let's go see what they said. Oh, they're making us write it in words. You can type it in words, but yeah, notice they got the same numbers here. But we're going to use the proper notation because it's good for us. So you're going to use these brackets, the fancy little brackety things. And I'll make this slightly bigger too. Who cares? You can see. Okay, so the domain and range of the other one, can I still buy the same number of flowers? Oops. Yeah. Domain should be the same because you're still talking about how many flowers you can buy. 1, 2, 3, 4, 5, 6, 7, 8. But instead, they have a different pricing system. So they have to charge $60 up front. Oops. Plus, so 50 cents per rose. That's the difference, which means that all of my numbers over here are wrong. Well, except for the first one. If I buy nothing, I pay nothing. That's for sure. However, if I buy 1, actually that's kind of weird. We're just gonna leave it as is. Technically, the way that they wrote the function, you don't want to use zeros. I might as well make it go away. If you want to try to figure out why that is, go ahead, but it's not that important. Okay, so 1 rose costs $60 plus 50 cents. So $60.50. 2 roses costs $61. 3 roses costs $61.50. That's another 50 cents per rose. And 4 roses costs $62. And so on and so forth. Whatever it is, you just take the number of roses you buy, multiply by 50 cents, and add it to 60. And there you go. So that's what we're looking for with our roses. We're going to say the same thing down here, only they use a ton of words. Isn't math so cool how you can just write that and it means all of those things at once? Now, you don't actually have to write the number of roses. I was saying that to help you remember what we're talking about. Because domain, it should be understood that that's the number of roses, especially because we wrote it up here. The domain is what X can be. And the cost is what Y can be. All right, that's important. Domain always is right to left on a graph. Range is always up and down. Use the data in the soccer team's tables to graph our roses are red and flower power data. Okay. Just so you know, just to save ourselves some time, there is an example given in the book. Use the data to make a graph. So they have these graphs right here. We'll talk about that in a moment. But let's figure out what range we want, okay? So notice these numbers, we want to be able to compare them. So we're going to try to use similar graph ranges, okay? Notice the number we order goes from 12 up to 43, from 12 up to 23. Yes, this one could count by smaller amounts. We're going to try to keep them simple. So we're gonna go 10, 20, 30, 40, 50, 60, 10, 20, 30, 40, 50, 60, 70. We're gonna count by fives. So each of these squares is 5. So this is gonna look like so. This is still 0. This is 10 roses. This is 20 roses. This is 30 roses. Why am I doing this? Think about that. Because I'm not going to be here to do this for every single assignment. You got to be able to pick your own scale sometime. Why did I use that scale? Think about it while I figure out the next scale. Well, actually, let's think about this. Do all of these numbers fit onto there? Yeah. Do they take up most of the space? Yeah, it's a little over half. I mean, I could count by more. It could be 10, 20, 30, 40. I could, actually. I think I will. This would be better because this will spread out my numbers a bit. There. Now, I would not suggest this for all y'all. Well, it's fine. We're going to have to eye some of these numbers, but the more that we can fit on the graph, the better. So I'm going to do the same thing on the other side for the record. So I'll do 0, 0, 10. 20, 30, 40, and 50. Great, that'll work. Now notice, when I'm doing this, every single one of the numbers has to be very clearly at a certain line. And if I go 3 squares to get to 10, I have to go 3 squares to get to the next 10 up to 20 and 30 and 40 and 50 and so on. Next, I got to do the same thing up here. I'm going to compare these graphs again. So let's see how they behave. Now I've got numbers that go, costs that go from 29 all the way up to 81. So I need to make sure that I get up to 81 at least. 10, 20, 30, 40, 80, 90, 100, 120. There are 14 steps. I need to make that to 80. So if I count by tens, it's bigger than it needs to be. 5, 10, 15, 20, 25, 30, 35, 40, 45, 60, 65, 70. If I count by fives, it doesn't work either. I could count by something in between. How about eights? 8, 16, 24, 32, 40, 48, 56, 64, 72, 80, 88. Hey, that's pretty good. But it still runs out before I get any further. So let's go with, I don't know, sixes. 6, 12, 18, 24, 30, 36, 42, 48, 54, 67, 54, 60, 66, 60, 72, 78, 84. Hey, that's kind of nice. Let's do that. 84, 72, 76. Wait, yeah, that's right. 78, 72. I'm not going to label them all because that sounds like a lot of work. 60, 54, 48. So I'm making every single square be 6. Why? Because this goes up to 84 and my highest number is 81. So I made everything as spread out as possible. in my graph. Everything's going to fit on there, but it's not all going to be in one little tiny corner. And that's our goal. 48, 42, 36, 30, 24, 18, 12. There, we made it through. I know this takes forever, but you don't have to watch me do it all. You can fast forward if you want. There, looks great. I'm going to do this really fast because this is just too much to redo. Control. I'll go back to here. Looks like it wants me to get rid of these guys first, and that's okay with me. There. Now I'm going to cut and paste the whole thing because it should line up with the other graph nicely. We'll see. Control C, Control V. Oops. Hey. Control V. That's what I'm talking about. Boom. So now I've got two graphs that have the same numbering. Okay, that's good enough. All right, so let's make our points. If I order 12 roses, I pay $29. That's about right. Roses, that's going to be, let's see, this is right there, and 29, around there. All right, 24 roses is going to cost 38, 23, 24. Each of these is about 3, about 23 and a third, 24 is just past there. That's the downside of splitting 10s into 3s. But we'll manage this. About 23 right here, 24, and 38. I need to go up to 38, 36, 38. And 36 roses cost $47. 33, 36 is going to be just to the left of this one, and $47 is going to be about right there. All right, notice they're making a straight line. That's good. 32 costs $44. Hey, that's backwards. Well, we'll go back to 32. It costs $44. That's about right. There. Oops. It doesn't have to be perfect, but you should notice that they're in a line. And 23 roses cost $37.27. 23 roses cost $37.27. Boom. Okay, so that's what I get. Over here, we have 12 roses costs $66. 12 roses costs $66. Boom. 24 roses cost 72. Am I doing this perfectly? Not exactly. 36 roses cost 78. 36 is about here. 78. 32 roses costs $76. 32 roses cost $76. And 43 roses cost $81. Up there. Okay, so these are our lines. Draw a line through the plotted points on your graph. Okay, I can do that. I just change it to a line. I'm gonna make it, it doesn't matter. Clearly, this is a straight line. Boom, something like that. And boom, clearly something like that. Okay, we drew lines, good job. And now we're going to talk about those lines. I can write Done. It's weird that they would draw a line below me like that. Okay, so we're going to talk about these lines for a bit. What do we notice about them? What do they say? If I have something instead of a table, a graph, what helps and what hurts? Now, one thing I will tell you is I made the scales the same for both my graphs. I know that took forever, but that's important if we're going to compare them, because as we've said a million times, I can change the scale of the graph and make it look steeper or shallower. But if the scales are the same, this counts up by 10 every 3 squares. This counts up by 12 every 2 squares. Same thing here. If we've got the same scale, then we can compare the steepness because they're in the same world, kind of. Okay? So which one looks steeper? Why is that? Think about those things. Could we ever figure out when one will cross the other? That's where we're going to go with this whole thing. All right? So let's take a look at what they've got to say here. Good job. We made a graph that looks like that. They counted up to 100. Sorry that I made your life difficult, but I felt like it. So this is their graph, but notice they use the same scale for both of them as well. It's important if we're going to compare them that they use the same scale. All right, you can compare the graphs. Here's what they got. What do you notice when you compare them? Is that the first thing we write down in here? I bet it is. It doesn't say anything. What do we notice about them? One thing I notice is this one's steeper than that one. Notice on our graph, it's the same thing. We used a different setup, but this one on the left is steeper than the one on the right. Same thing. So that is an important thing to notice. Beyond that, they're straight lines. I don't know. You compared them. Now you can solve a puzzle, finding similarities and differences. Let's figure out on both graphs, they what? Okay, we're going to use some new vocabulary. So these are the graphs we're talking about. So both graphs, the plotted points fall in a line that is what from left to right? What's happening to the line as it goes from left to right? Is it rising, falling, lower, higher, increases, and decreases? I guess they're trying to say rising. I would say increasing. It's interesting that what they put is there, so whatever. We're going to say rising. I would say increasing if it were up to me, but that's not a choice. So we're going to follow the rules of English, and we're going to write rising. Okay, because they do get higher as they go from left to right. The shapes of both graphs show a steady increase in the cost of roses as the number of roses ordered. Also, so if the cost goes up, what's happening to the number of roses they order? It's also going up. We would say that's increasing. The rose, this red line starts what, but is steeper. Let's see. The roses are red line, this one starts lower, but it's steeper. Would you all agree? I would agree. Compared with the flower power graph, this shape means that the service charge for the roses is what, but the charge per rose is what? Okay, so remember the service charge is how much they start out with. So they charge $20 to start out with here and $60 to start out with here. That's why we start at 60. These guys charge $60 service charge plus 75 cents. These charge $20 plus 50 cents. These guys charge $20 service charge plus 50 cents. So what we're noticing is, sorry, I'm saying all the wrong words. I'm sorry. Here it was. Well, it's not written anywhere in this assignment, so we might as well write it down. $20 plus 75 cents, no, 50 cents, nope, 75 cents per rose. This one was $60 plus 50 cents per rose. And here's what they're noticing. This one starts lower, but it's steeper. That's because it has a lower starting cost, but it charges more per rose. This is called the service charge, and this is called the cost per rose. Let's see what that's saying then. So because the one on the left starts lower, but is steeper, that means that its service charge is lower or less. But the charge per rose is higher. That makes sense. Okay, continue your analysis of the graphs by filling the blanks 9 through 15. The roses, our red line intersects the y-axis at the point. Let's take a look. Roses are red, it's intersecting somewhere around there. Let's see, where is that? Let's look at their one. Crosses at 20. In my one, yep, that's about 20. I just can't see it as well because I numbered it differently. Hey, look, that's 20. What is that? Now, here's a weird thing. Usually we just write 20, right? It crosses at 20, but it says at the point. That's an important thing to notice, point. Whenever we say point in algebra, we're talking about an actual point on the graph. This is just a number. So whenever it asks for a point, we're going to give it a point. So I need to put numbers in there, two numbers, an X and a Y. Okay, now, so going back to here, we know that this is the place where Y is 20. What's X? Well, X is 0. So that's the point, 0, 20. So I'm going to type in 0, 20. That's what they mean when they say point. All right, flower power, on the other hand, crosses right here at 60. That's the point where X is 0 and Y is 60. 0, 60. So let's type that in. 0, 60. Easy. These data points on the y-axis represent the cost of the what for each company. What was this number called, the 20 and the 60, this number? They called it their service charge. We just dealt with that. Service charge. Okay, if the soccer team orders 45 roses from Roses Are Red, they will pay about what? Let's look at 45. 45 is right here. Well, somewhere, we're smack dab between 50, so it's right there. It's going to be around halfway between 48 and 60. What's halfway between 48 and 60? That's 54. About $54. Oh, they already gave me a dollar sign, so I don't even have to make one. Isn't that nice? Okay, if I order 45 from the other group, what do I have to pay? 45 is right here. Oh, like 84 or so, huh? About 84. Now, is this perfectly right? Am I getting the right answers? That's a good question. Did they say, they said about, and we didn't have a graph that was very clear, did we? This is a difficult thing about graphs. Graphs can tell me a lot of information, but the formulas we used before would be a lot better way to figure it out. You'd plug in 54, and you'd plug in 40 roses, and you'd find out what it makes. Let's see if their graph helps a little bit more. 45, no, their graph, we just have to guess there too, don't we? And that's okay. So if you've got a graph and they say about, then you can kind of guess. Oh, look at that, they had all of that fun stuff. All right, moving back to our assignment. For Roses Are Red, soccer team can get about what roses for $70? The flower power, how much they can get for $75. So let's look, or $70. $70. That's the cost right here, right? Oops, I forgot to write cost. 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 And number of roses. And I'll just write it on the top of there, who cares? Number of roses. That's fine. Okay, just to make sure we got $70. So $70 is between 60 and 72, isn't it? It's right below 72. Uh-oh, that doesn't have that information on this graph. On this one, though, I could figure it out. 70, it's going to be right there. It's going to cost about, it's going to be somewhere between a little over 20 roses, like 22, 21 roses, something like that. Let's see if they've got a better setup. I think they might. If you're just going to copy theirs, then they've thought a little further in advance than us. You can see more information about this situation than whatever. Okay, 70 roses. Hey, look, they have different numbers than us because we're guessing. But roses are red, $70. Let's see, that's here. $70 is going to be about 60 something roses. 66 looks good. Flower power, $70. $70 is going to be about just over 20 roses. Or just near 20 roses. Maybe they think it's going to be less than 20. Their graph isn't very good. None of the other numbers work though. Notice 18 goes up to about 70. Yeah. So those have to be the answers. Notice I start at the one I want. So I start at $70 and then I follow it down to where that works on the other thing. So for example, if I have 45 roses, 45 is right here. I go up, that's going to be 80 something on this group. And then if I do 45 roses on roses are red, that's 45, about 55. So we're going to put in 66 and 18 for our next two answers just because they work better on their graphs because, what was it, 66? And I'll go back, 66 and 18. Definitely can get more roses for $70 at Roses Are Red, can't you? Okay, so that was fun. Now we're gonna rent some vans. Yeah, from Vince's Vans and Carla's Cars to Go. My mom's name is Carla. That's awesome. Okay, which van rental company begins to charge you money as soon as you rent the van? How do you know? Okay, so we're gonna figure that out. All right. We're going to take a look at this. So how could I figure out the answer here from this situation? I don't care too much about backstories, but here's what we notice. Here's what we could do. First of all, with my graph before, we knew I got charged $20 to start out and $60 to start out because that's where it crossed here. So if I look at Carla's to-go cars, think about how I could figure out if she charges money from the very beginning before you drive any miles. Look at the line, think about it. 5, 4, 3, 2, 1, done. Okay, so here's what you need to notice. If I continue this line, oops, I should probably continue it as a line now instead of like a squiggle. And it's going to go about to 50. So that's her surcharge. That's how much she charges to start out with, right there. Well, that's cool. I didn't want to do that. Well, now the question is, so we can say, Carla, by following the line to the y-axis, I can see Carla charges a service fee, whatever. That's what we called it when we were talking about the roses, of $50. And how would I figure it out with Vince's Vans now? Think about that. I'm going to give you a hint. It's going to have to do with subtraction. 5, 4, 3, 2, 1. Pause it if you need more time. All right. I'm going to go ahead and I'm going to look at these two numbers. I'm going to ask myself, how far apart are they? How do I figure out how far apart they are? I can subtract one from the other. So 2250 plus what makes 45? I'm going to subtract it right now. I'm going to take out my phone. I'm going to log in. I'm going to take my calculator and I'm just going to go, what is 45 minus 22.5? 22.50. It says 22.50. So I know that this is going up by 2250. Now, if I go from 45 to 6750, guess what I get? You'll never guess. I just don't believe you'll ever guess. The truth of the matter is, if I go from 45 to 6750, it's 2250 more. And if I go from 6750 to $90, it's 2250 more. It always goes up by 2250 every single time. And I can find that by subtracting. Subtract the smaller number from the bigger one and you'll find out the bigger one is 2250 more than the one before it. Each time it goes up by that much. That's like our slope. We'll talk about that more, or our rate of change. However, here's the thing we notice. If this goes up by 2250, then if I go down one more, I imagine there's another step ahead below. This would go up to 0. This guy would be 0. Let's see, I'll just go. The left side would be 0 because it goes up by 50 each time. And the right side would go down 2250 and be at 0. They're both 0. If you drive 0 miles, you get charged $0. So, what can I say about Vince's vans? Vince does not charge for 0 miles. I can each 50 miles costs $22.50. If I continue the table upward, I get 0 miles costs $0. Oh, miles, 0. Hopefully that makes sense. And that's what we got there. Great. Let's look at this guy. Consider the two graphs. Does each represent a function? Why or why not? Now remember, functions are, if I tell you an input, I can only have one possible output. Remember also, domain or the input is always which letter? That's right, it is X. X is our input. So, knowing that, think about it. I'm giving you 5 seconds or a pause. All right, so the thing we're looking at here is a function is function given an X value, input, there should be only one possible Y value output. That's what we're looking for. So over here on the left, if I tell you X is 4, you can tell me that Y is about 3. If I tell you that X is 8, you can tell me Y is about 10 or something. If I tell you X is 5, you can tell me Y is about 5. You can figure out, based on what I tell you for X, you can follow it up and go, oh yeah, so Y is that number. If X is 10, then Y is like 4 or something like that. I don't know. I'm just eyeing it. But you can see, if I tell you an X, you can find out a Y. Let's try that over on the right side here. If x is 3, y is clearly about 4. If x is 10, y is clearly about 8. But in between, we run into troubles. What if x is 5? Well, y might be right here, because that's part of the line, like 3-ish. Or y might be 5-ish. Or y might be way up here around 10. So if I tell you x is 4 or 5, that messes things up. You can't tell me what y is because it could be 3 different things. It could be up here, or down here, or at the very bottom down there. All of those are possible things. So the first graph is a function. Given an x value, you can always estimate the single y value. Let's scoot this over a little bit so it doesn't. The second graph is not a function. Given the x value 5, you can find several possible y values. Here's a fact that you should know. Vertical line test. Any graph that can be crossed twice with a vertical line is not a function. Or any graph that is ever above itself. Okay, so basically, if I have a graph where one part of the graph is above itself, then it's no longer a function, because both of these things are 2 different y's coming from the same x. So if x is 5, that's a line straight up and down right here, like this, like so. Y could be right here. Oops. There. Y could be right here, or right here, or right here. I don't know which of those y's is there. Notice I just drew a vertical line from this x value. So if x is 5, y could be all sorts of things because it's above itself. This graph is above itself. A vertical line goes through more than once. So this is what we call the vertical line test. And it is a thing. It's an actual thing. You can look it up online and go, oh, the vertical line test. So if you're ever asked if a graph is a function, there's a really easy way to check. If the graph is ever above itself, so it's above itself, see? Another way you can do that is, well, it's the same thing as a vertical line test. Another way you can think about it though is if a vertical line goes through it more than once, then nope, then it's not a function. So that's useful to know. Oof, there's a lot of stuff in this assignment. Literacy task. Which flower company should the soccer team use? After analyzing the offers of the blah, 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 write a memo answering the question in which you justify your recommendation using evidence from the tables and graphs for each offer. So think about that. Here are 2 groups. We did this in our last assignment too. There is a good reason to use flower power based on certain numbers, but it certainly doesn't look very promising right now, okay? So think about how many flowers you want to order, and that will be a big, big part of which one you choose. I am not going to tell you the answer to that. You're going to have to give me a decent thing. I'm just going to say, this is my answer. depends on how many flowers you order. I would choose because that's for you to write. I'm not going to write that in there because that's just a waste of, well, you can figure it out and think for yourself. All right, you can be wrong, but I want you to give it some thought. Which is a better deal and why? For flowers, remember this is the flowers. Okay. Okay, the online rate, oh yeah, we stock it. Yeah, those guys, posts its charges for shipping and handling, blah, blah, blah. We did this before. $1.50 per pound and $5 to handle the package. Great. Their competitor is Discount Store. Whoa, they made it very difficult for its customers to find shipping and handling fees on its website. A group of customers posted data. Wow. So this is some information what they got charged for sending different amounts. If you made a graph of the retailer's shipping costs, which variable would you graph along the x-axis and which variable would you graph along the y-axis? Why? Okay, so we're going to turn this into a graph clearly, the way they're talking about it. So what would I use? Cost or how much it weighs? Now remember, they're saying we charge this much money plus a little bit extra every time that every pound more that something weighs. So they charge based on the pound of what they send in the mail. Okay, so what depends on what? Does the weight depend on the cost, or does the cost depend on the weight of the package? And the answer is 5, 4, 3, 2, 1. The weight affects the cost. The cost depends on the weight. So cost is dependent. Weight is independent because the cost depends on the weight of the package. There. All right. So we got that. Great. So now we're going to have to make a graph of it. Oof. And we're going to draw things. So let's look at this numbers. We got numbers that go up to 20. We got numbers that go up to 40. That's easy. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. Oh, looks like we're going to have to count by twos. 2, 4, 6, 8, 10, 20. And it'll be fine. So we're going to make this back to 12 or so. 0, 2, 4, 6, 8, 10. 2, 4, 6, 8, 10. 2, 4, 6, 8, 10. There. Okay, so that's that one. And so I've got, that definitely goes up to 20. So I've got my weights. This is my weights. Ugh. There it is. Can I spell even? I forgot to spell. W-E-I-G-H-T. Wow. So 2, 4, 6, 8, 10. There we are. We're back to where we were supposed to be. I was just writing in the, and then we've got our cost over here. Cost. Our costs could go up to 40. So we don't want to count by tens here. There are 14, I think. Lines. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 15, 16, 17, 18, 19. 19 lines. And I need to be able to fit 40 on there. I got to 40 about 20, about halfway through. So I can go up more than 40. Let's go to let's see, 14 times 4, 14 times 5, we'll count by 5s. 5, 10, 15, 20. I'm just going to count how much. 25, 30, 35, 40. 45, 50, 55, 60. 65, 70, 75, 80. There, great. Notice I always have to count from 0, and I always have to continue counting the same amount. That's important. Okay, so let's finally graph these points. Our points are 3 is 925. 3 packages is 925. I'm going to make it 4 because this is a pretty small graph, and I'm going to make the dot 0. 3, this is 2, 4, 6, 8, 10, right? So 3 is right here, and we said 925, 5, just under 10. Okay. All right, so let's look at the next point. 5 costs $12.75, so I'm going to find 5 on here. 2, 4, 6. Here's 5. We said $12.75. 5, 10, 11, 12, 75, about there. All right. 12 is going to be $25. 10, 11, 12 costs about $25. That's right. Smack dab on that line. 12, $25. All right, 35, 50, and 18. 18 is right here, and 35, 50 is right. 35, 50. Just a little bit above 35. Okay. And 20 is going to cost $39. 20 is going to cost $39. There. Okay, so we got these points. They kind of make a line. Let's see what that line looks like. Something like that. Are they a perfect line? No, that's because I drew it all by hand. If you make a handmade graph, then you're going to run into some troubles. Okay. Do they only charge by the pound, or do they charge a flat fee like we stock it? Do these guys charge a fee? You know what? It looks like they do. They charge like $3 as well, something like that. How do I know? Because this line doesn't go down to 0. It goes down to a point where it's above 0. So somewhere between 0 and 5, they charge that fee. So that's what we're looking for. They do. I know because the graph of the line hits the y-axis. We're going to say intersects the y-axis because it's good to use our fancy math words. The y-axis above 0. And that's it. Okay, case for printing paper weight. A case of printing paper weighs 28 pounds. How much would either retailer charge for shipping and handling of the printer paper case? 28 pounds. So let's see. How could I do that? Well, I might want to look at this. I'll make my line go a little bit further. That wasn't a very good line. Something like that. So if I wanted to buy 28 pounds, that'd be 22, 4, 6, 8. That would be about 55. So I could go 28. X is 28, and Y is about 55. That looks like about right for this graph. I wonder how we would find it out for the other one, but I guess Either retailer. Did they give me the other retailer? Oh, here they are. Okay. These guys would charge, let's see. For these guys, if we had 28 pounds, would be, let's see, $5 plus $1.50 for each pound. So it'd be $5. So it'd be $5 plus $1.50 times 28 pounds. 28 times 150, that's gonna be 28 plus half of 28 is 14. So that's gonna be 28 plus 14 is 30. 38, 42. 42 plus 5 is 47. $47. Okay, so these guys would cost 47. Those guys would cost about 55. I can use the formula to find that we stock it. We stock it. Would charge $47 for 28 pounds. I can use the graph to estimate that 18, and we'll make it all black. To estimate that what? These guys, discount store would charge about $55 for 28 pounds. There. All right. Hopefully that makes sense how I got that. Please always ask in class if you are confused. We will make that red so it matches. Okay, that was the last bit. We did it, my friends. We answered all of the questions in this god-awful, really, really long assignment. Hopefully, that's all we will do before Thanksgiving. Although I would like to do more, I really would, not gonna lie, but I'm stopping for now. Stop that recording.